Hi everyone, I hope I am audible now. Okay, so sorry about the previous session where I wasn't audible properly. So this is the new session on data science that we have on Coding Ninjas. So firstly, welcome all of you to the YouTube channel of Coding Ninjas. And this live or this session is a part of a new series that we have started on Coding Ninjas YouTube channel. So the link to the entire playlist of the series is given in the description below. So this is a series that helps you with data science from the very basics. So if you're a fresher or you're a beginner in data science, this is the right series for you. And I do recommend you to check it out. This series is about 50 videos and the link to the playlist is given in the description below. I am Jishnu and I will be taking you through the session today. Apart from that, Coding Ninjas also has a course dedicated to data science on their website. So I would recommend that you look into that as well. That course comes with about 12 projects. And if you are really interested in data science and you want to learn a lot, that will really be helpful for you. And these courses will definitely help you learn a lot and also boost up your resume. So apart from this, you also get expert tutors who will there to help clarify all your doubts. So without any more further ado, let's get started with today's video. So, okay, let's get started with today's video. Firstly, uh, what is data science, right? So data science is, okay. So So today, everything we do has data science in it. From you booking your cabs or from you looking at Google Maps when you want to get the best route to you getting recommendations on Netflix, everything today is data science, right? So, okay. So today we will be discussing on what actually data science is all about and how data science is being used in the industry today. Apart from that, we will also be looking uh, at the different uh, skills that you need to learn to become a good data scientist and the different job prospects that are there and the different courses that you may have to take or different kinds of projects that you may have to build. So, okay, just give me 1 second. Okay, so okay, so as I was saying, what is data science? Data science is all around us today. Everything that we do has data science involved in it. So we have our Google Maps. When we go on search for the right location, or the best route is suggested by Google Maps. So that is data science. And we have our Netflix recommendations that happen. So all these things that may seem mundane for us when we do these things daily, but they're actually data science models working behind them, right? So today in this video, we will understand the basics of data science, and we will also look into the data science. How do you build your resume and things like that. So let's get started. L- You also might have heard about the terms machine learning, deep learning, and artificial intelligence, right? So you might be wondering what the difference between these terms actually is. So we will be discussing that also now, and how it all relates to data science, right? So artificial intelligence is us, or as humans, we trying to give machines the capability to make decisions on their own, to learn on their own, and to do different tasks that we ask them to do, which might be difficult for us, or which are traditionally designed only for humans to do. Like for example, there are some tasks which machines definitely do better. Like for example, you say 347 into 292. So this definitely a machine will be able to answer faster, right, than a human. But can a machine drive a car on its own? No, it cannot for now. So there's so much of research happening there, but for now it is not very common. So that is where artificial intelligence and machine learning and data science come into the picture, right? So we want to give the capability of taking their own decisions, and tasks that are reserved for humans today, we want those to be done by machines as well. So that is what the main aim or the main goal of artificial intelligence is all about. Now, what is machine learning? Machine learning is a subset, or a, a set of techniques that, with the help of statistics, we try to accomplish a few tasks in artificial intelligence. So in machine learning, what happens is we using the data that we already have and things like that, we try to train our systems to act or to behave or to make decisions like humans. Then we have the deep learning, which is another subset, or another uh, small uh, small thing inside machine learning. So deep learning is actually inspired from the human brain. Like there are many neurons and they are connected to each other. So all these inspirations have been taken from the human brain, and we try to implement it so that we can make our machine learn better. Now, what is data science? So data science is the field that takes in all these techniques, and using all these techniques, and with the help of data, we try to solve business problems or problems that are there in general in the world. So this is the basic idea of data science. From data, or using data, we try to solve problems. So now that we've understood the main goal of data science, let us look into some important applications of data science. Okay, so let's go ahead with that. The major applications, a few of the major applications today, or as we've discussed, data science is being used everywhere. So a few of the major applications today are healthcare, and even inside healthcare, there are many. subdivisions or subclasses of applications that we have. Like for example, we have a lot of research happening in disease prediction that is basically helping out doctors to predict diseases based on the symptoms and based on the other factors that the patient has. We are having medical tests. We are having medicine recommendations or drug recommendations. Then we have insurance claim verification, that is in especially in huge insurance companies, this is of a lot of use. So this also again further requires many different applications of data science. Like for example, um, uh, you may need OCR, that is from text to that is from written text to machine text, or on the text digital text. So these kind of applications might be required in the insurance claim verification process as well. Then there's a lot of research happening in genetics. There is a lot of research happening in chatbots for mental health. There are chatbots today giving therapy sessions and helping people feel better and come out of problems like anxiety and depression. Then there is tracking patient problems or helping patient to solve or take his drugs regularly and such kind of things. So there are so many different applications within the field of healthcare as well. Now, another important application is recommendation engines. So recommendation engines also are really being used in a huge way today. Like you have your movie recommendations, you have your product recommendations on e-commerce websites, and you have directed advertising that's happening. You have you have search engine optimization, you have videos that come like related videos on YouTube, related movies on Netflix, etc. So all these things also are major applications of data science. Apart from this, you have your image recognition for that is being used in security. You have your fraud detection in you have your fraud detection in credit card or bank transaction fraud that can be identified easily using this. You have your anomaly detection, which is useful in many manufacturing and all other different kinds of production environments. Okay, then you have your voice to text, which often you use in your smart assistants that you have on your phone, uh, or your Alexa and things like that. Then you have your bigger applications like self-driving cars and so on. There are so many more applications, right? So so that is the reason, because there are the applications of data science are so wide, and in almost every field the requirement or the need for data scientists is increasing so much. So so this is the reason why the need for data scientists has increased a lot today, and we are also everybody is trying to become a data scientist, and it has become a very good career option. Now let us look at the different kinds of algorithms that are there in data science, or the different kinds of uh, machine learning algorithms rather. So so what are the different kinds of machine learning algorithms that are there? The first one would be the supervised learning algorithms, right? So now what is supervised learning? In supervised learning, we always have a labeled data set. Okay. So now we've already discussed that data science or machine learning algorithms is all about the data that we already have. So we have supervised learning algorithms or supervised learning techniques when we have a labeled data set. That is, we have the input for the data, or the input data that is actually used to train our model, and we also have the output data which is used to uh, train. Basically, we given the input and the corresponding output in order to train our model to understand or to learn better. Okay, So this again has two further classifications. One is regression and one is classification. So now how do we know when we have to use regression and when we have to use classification? So we know that we have to use supervised learning when we have a labeled data set, that is the data set has the input as well as the output, right? Now, how do we know when we have to use regression and when we have to use classification? So basically we use regression when the output data is a continuous data, right? So output data should be continuous. That is uh, 1, 2, 3, 7, 9 or anything like that, but the data is continuous. You can have decimal values, you can have huge numbers, so anything. So that is when it is continuous. Then you have your classification, which basically is your output data is in categories or classes. So let's say you have a set of images and you want to predict whether this you have a set of images of cats and dogs. So you want to classify between dogs and cats. So you want to classify your images, which images are dogs, you want to send them into dogs, and you want to send your cat images into cats. So, and you want your machine to take this decision on its own. So how will it do this? So in this case, we will be using classification algorithms because we have two separate or we have two entirely different classes and we want all our data to go into either one of these classes. So that is when we use classification. There are two classes here. So our output data, all our output data belongs to either one of these categories. So these are also called classes. So either one of these categories or classes, and this is basically your classification. Now, classification also has two further uh, sub types of or divisions in the types of algorithms. So you have the first one, which is binary classification. So binary classification is basically when you have only two classes. So this case where we have dogs and cats, this is a binary classification problem or a binary classification that is happening here because we have only two classes. Then you have your multi-class classification where we multi-class classification where we try to have more than two classes. Let's say we have a third animal here. Let's say some bird or something. So then in that case, this becomes a multi-class classification problem. Okay. And apart from this, another important example or a daily use example of classification is that we have spam classification in our emails, right? So when a new email comes into our inbox, it gets analyzed whether it is spam or non-spam, and it goes into the corresponding category. So when you have two classes, spam and unspam, in that and not spam, that uh, becomes a binary classification problem. And when it is not when we have other classes also, right, in our Gmail where you have your promotions or you have your social, so in that case when you're classifying into so many classes, it becomes a binary classification, it becomes a multi-class classification problem. Okay, so this is basically about supervised learning. You have certain different algorithms in either of these. So in regression, you have algorithms like linear regression and so on. And in classification, you have algorithms like logistic regression, decision tree, and so on. Okay, so this is basically about supervised learning. Now let's go ahead and look into unsupervised learning. Okay, so what is unsupervised learning? So as we have discussed before, supervised learning is done when we have a data set that is labeled. That is, we have the input and the output data set. output data in the data set. So when do we do unsupervised learning? It is the opposite of that. When we do not have the output data. So only the input data is present. We do not have the output labels. We do not know what the predicted output should be. So that is when we use unsupervised learning. And in unsupervised learning also we have two types. One is called clustering and one is called association. So in clustering, what happens is we have the data that is there in let's say we have a lot of data here. We only have the input data. We do not have the output data. So based on the different features that are there in the data set and based on the different properties of the data, our model learns on its own, learns the features on its own, and it will be classifying or dividing the data into clusters. So dividing it into groups or clusters. So this is similar to the classification tasks that we have seen before in supervised learning. The only thing is that here we will not be having the output data set. So clustering, this is how clustering works. Based on these properties, we find out how close or how far away these points are to each other, and the closer points, the points which are closer to each other are classified into one separate group based on the number of groups that we want to break our data set or data into. Now we have the second thing called association. In this case, our machine learning algorithm or our model learns from rule-based. This is like a rule-based approach. So in this, we have certain rules based on which our machine learning model learns and tries to predict for future occurrences. The next kind or the third type of machine learning algorithm that we have is called as reinforcement learning. Okay, so in reinforcement, what happens is in reinforcement is mainly used in applications like gaming technologies and where you have a lot of options or a lot of predictions that can be made. So in, for example, in a game of chess, you have so many different moves that can be made, right? So in these cases, reinforcement learning is very useful because what happens in reinforcement learning is the machine makes a prediction, and based on whether the prediction or whether the prediction that it has made is right or wrong, it will learn again on its own. So it will initially it will make predictions randomly, and we will be defining certain rules based on which it will decide whether the prediction was right or wrong initially. So eventually, initially it will be making random moves, and based on whether it is right or wrong, eventually it will understand, well, if it has made a wrong move, it will understand that, oh, I should not repeat these kind of things again. If it is a right move, then it will add points for itself and it will say, okay, this is a good job. So based on the move that it has made, or based on the prediction that it has made, if it is right, it will say this is good. If it is wrong, it will try not to repeat the mistake. So this is somewhat like how humans behave, right? We try to act in such a way that we do not repeat our mistakes. So this is how reinforcement learning works. This is mostly used in gaming technologies and basically games that you have. So now that we are done with the different types of machine learning algorithms that are there, we can go ahead and look into one of each type of supervised and unsupervised so that we get a better idea on how these algorithms or how these techniques that we have are actually working. Right. So before that, I have gotten a question here which says, what is the average salary of a data scientist? So the average salary of a data scientist may vary from like 5 lakhs a year to 25 lakhs a year based on some research that I've seen. So that is true because it's based on the company you work for and the kind of work that you have, but it ranges from 5 to 25 lakhs in different companies based on the kind of projects that the company is doing and the size of the company and other stuff like that. So if you work for smaller startups or smaller companies, you may be being paid lesser. So it depends on that. But that's the range that I wanted to mention. Now, apart from this, let us go back to our whiteboard and let us try to understand the different skills or that we need and to become a data scientist. And even before that, we will be discussing one type of algorithm or one algorithm of each of the supervised and unsupervised learning methods. So in supervised, let us discuss about regression, right? So in regression or majorly in linear regression, which is the most used algorithm or most used supervised learning algorithm, in this we will see how this works. So in linear regression, what we try to do is we have all the data points. So this is a supervised learning model. So we have the input as well as the output data with us. So let's say our data is in some way like this. Okay. So what linear regression models try to do is that they try to build a uh, they try to draw a line which is the closest possible line or which is very close to all the points that are there in our model. So we draw our line in such a way that our model is close to or our line is close to all the points that are there in our data set. So we try to find out the best possible line, and based on using that line, we will be making the future predictions. Now let's say this is our line. Okay, and we have in future we get a in the future, let's say we are getting a another point whose prediction we want to make or whose output prediction we want. So in that case, we will be using this line, and the y coordinate or the output coordinate of this point, we will be giving it out. Let's say we've gotten this x value and we want the y value of the, let's say y is the output prediction. Um and we have our x value. Using this line, uh, we will be calculating or we will be finding out the output value, which will be very close because we've drawn the best possible line. Now, how do we find out this best possible line is what we will be seeing now. Okay, so usually in math, you define an equation or you define uh, a straight line using this formula, right? Y is equal to mx plus c. So just keep this in mind. We will be using this here. Before that, I would like to show you some of the or let you know some of the important nomenclature or jargon that we use here in machine learning. So the input variable is always represented by x. Okay. So let's say this is the input variable. Then we have the output variable, which is defined by y. So your input variable can have multiple features, right? So it can be x1, x2, x3, and so on. And your output variable y will have y alone. This y is the actual output which is there in the data set. Because this is a supervised model, let's say this y is the actual output of the data that is there in the data set that we already know. Okay, and the predicted output, that is the output predicted by our machine learning model, is is always represented by y cap. Okay, so these are some things that you need to know. And a data sample is represented by x comma y. This is one sample, and because you will have a lot of data, you represent it using an I. So this will be your ith sample of data. So if you say x comma y of 1, this will be your first sample of data that is there in your data set. Okay, so you can also call it as 𝗖𝗍𝗂𝗋𝗋. Okay, this is also possible. And in case you have more than one variable, your x becomes a vector and you represent it by x bar. Okay, so these are some things that you have to know. And yeah, so now let us go ahead and see how this regression algorithm is working. So we have already discussed about y is equal to mx plus c, right? That is how the straight line is defined in math. So here in machine learning, we use f of x is equal to wx plus b, where w and b are called the weights or the coefficients. Okay, so this is what w and b are known as. And basically, because your line equation also depends on w and b, you write fwb of x. Okay, so this is how you represent your straight line that we want to form. So now how do you get the perfect line? Or we are using only one variable here to make our work easier for now. So how do you get the perfect line? So we get the perfect line basically by getting the right values of w and b, right? So now how do you get the right values of w and b? So what we do is we keep changing these values of w and b at infinitesimally small amount, and when we get the right line we stop. So how do we decide that the line is the right line or the perfect line, or it is closest to all the data that we have, right? Uh, so what we do here for that is we have something called the error. Now, from the name itself, you may understand that error is basically nothing but the predicted value by our machine learning model, and it is the difference between the predicted value of our machine learning model and the actual value. So this is the error. Right. So predicted model is what? It's nothing but predicted value of the model is what? It's nothing but this value, right? You just substitute the value of x and w and b values that you have. Whatever you get, it's the predicted value. So that you plug in here, and the actual value of y you plug in here, and you get your error value. So this is basically the difference between the y cap and y, which is the error. And you want to minimize your error, right? So you want to minimize your error. The lower your error goes, the better your model is working, right? So that means the line is closer to the points. So wherever your error is the lowest, that is where we will stop the changing the values of w and b, and we will finalize those values. Okay, so how do we get that? What we first have to do is we have to minimize this error value, or error the total error that we are getting. So let us just first substitute these into these y cap and y. So let's say wx plus b minus y. This is the error that we have. Okay, so now based on this error value, or the error value that we get here, is for one sample, right? Now how do we do this for when we have multiple samples? Because we can't just judge based on the error of one sample, so we need to calculate this for all the samples. So what we do is we calculate the sum of all the samples of the we calculate the sum of all the samples that we have in our data set. Let's say we have m samples in our data set. So we calculate the sum of all these. Now the sum also is not giving us the right measure to reduce, right? Because as we increase the number of data samples that we have, or as we increase the size of the data set that we have, this sum will also definitely increase. So the best method for that, or the best way to get the right thing, is to get the average. So we do 1 divided by m, and we also add a 2 in here because that doesn't affect much, it's just a constant, and it makes our calculations easier later on. Okay, so now we have this equation, right? Now, one more thing that we do here is we have the error, and we also give the get the error into a square so that we do not have to deal with this modulus. Okay, so because y might be bigger or sometimes y cap may be bigger, so that we don't have to deal with that, we square this. Okay, and this error function is called mean square error. Okay, this is 𝑖𝑥𝑖 and 𝑦𝑖 because we are giving different data samples. So this function is called mean square error because we are squaring the error and we are taking its mean. So basically this error value, if we reduce, our overall line that we are generating or this equation that we are getting will be the closest to all the points. So for this, what we do is we calculate the W and B. Now, how do you reduce a function, or yeah, so how do you reduce a function? We use differentiation in calculus, right? So that is what we will be doing here. So I'll not be going into the calculations here, but when you differentiate it and you minimize this function, you will get the exact or the perfect values for W and B, and those you will be plugging into this equation that you have here in order to get the perfect line, which will then be used to make the predictions for the future sets of data that we have. Right. So I hope that's clear now how regression works. So that is how regression works. And basically this is how linear regression works, and we have considered only one variable here, right? We have considered only one x variable here, so that is why this is called single linear regression. In single linear regression we have only one variable. There's also something called multiple linear regression. Obviously the single, there's multiple linear regression also. That is when we have more than one variable. It is completely different from multivariate linear regression. That is something you need to keep in mind. So this was one kind of algorithm in supervised learning. I hope you got an idea about that. Now let us move forward and go into unsupervised learning algorithms and see how they work. Okay. So now what happens is unsupervised learning. In unsupervised learning, we have only the input data set. We do not have the output data set, right? So based on the input data set alone, our model or our machine learning model should be able to learn on its own and try to make the distinction between the different kinds of data that is there. So what do we do for this? How does this work, or how do we do this is what we are going to see now. So we will be looking at the first kind of unsupervised learning, which is called clustering. Okay, so in clustering, we will be looking at how the different classes are being formed. So I already gave you a small intro that based on the features that we have, the distances between the different points that we have, the model will learn and it will make the distinctions. So, or it will differentiate into the different classes that are there. So how do you calculate this distance, or how do you understand, uh, how do you get to know this distance, or the um, or how close these points are to each other? So there are a few ways in which we can do this. I will be discussing that now. But before that, let me just tell you where and all unsupervised learning's clustering mechanism is used. It is usually used in data reduction. Like for example, you want to remove certain kinds of examples or certain kinds of samples from your data set. That time you will be using clustering. Okay, you have your data cleaning here, then you have your predictions when you want to predict in groups. That is, you want to move or make your predictions in groups. And the most important application is your classification, or breaking your data set into separate classes. when you don't have the labels. Okay, so the major applications or the major algorithms rather in this clustering are k-means. K-means is the most popular algorithm that uses uh, that is used in clustering. You also have your agglomerative clustering, which is also very useful. Okay, now apart from this, you have let us just look at the different distance approaches or the different measures of distance that are there. You firstly have your Manhattan distance. Okay, so in Manhattan distance, what happens is you have to basically all these distance formulas are to calculate the distance between the 2 points, right? Between any two given points. So let us say we have a point x1, y1 and another point x2, y2. Okay. Or let us say rather the better option would be, because the number of features might differ. So let's say we have x1, x2 and y1, y2. So the formula for Manhattan distance in this case would be um, modulus of x1 minus y1 plus modulus of x2 minus y2. So this can continue for any number of variables. Like if you have 5 features, it will be x1 minus y1, x2 minus y2, x3 minus y3, and x4 minus y4 plus x4 minus y5. So that is how the Manhattan distance is calculated. Then you have your Euclidean distance. Okay. In Euclidean distance, what happens is you calculate the square root of x1 minus y1 whole square plus x2 minus y2 whole square and so on. So basically you calculate the sum of the squares of the differences of the points that are there and take the square root of that. This is how Euclidean distance works. So basically you have some more similarity measures. Uh, these are the distance measures. Basically these are the distance measures. So the farther the points are apart, that is the higher the distance is, the more the chances that they are in separate groups or separate clusters and not in the same cluster. Similarly, just like distance methods, you have similarity measures. So in similarity measures, what you do is you find out how similar 2 points are to each other, and based on how similar they are, you either keep them in the same cluster or you move them to different clusters. So you have similarity formulae, like you have simple similarity or simple matching, which is basically the uh, dot product, or you basically multiply xi and yi. So if you have only two here, so x1 y1 and plus you do the summation of that. So x1 y1 plus x2 y2. So this is how your simple uh, similarity works. Similarly, you have a few more similarity measures that are there, which are used to calculate uh, the whether the two clusters or the two given points are in the same cluster or not. So you basically decide on which points go into which cluster based on the distances. So the higher the distance, the 2 points will be in different clusters, and the lower the distance, the 2 points will be in the same cluster. So for 2 points to be in the same cluster, their distance has to be low or their similarity has to be high. So that is a given. Anyways, if your uh, distance is low, your similarity will definitely be high, and if your similarity is low, your distance will be high. So that these two are basically inversely proportional. So your distance is inversely proportional to your similarity. Okay. So this is how your clustering algorithms work. Now that we've discussed the different kinds of algorithms that are there, and we've gone into to see how either one type of algorithm in each of the supervised and unsupervised works. Let us now look at what kind of resume you need to build, or what is the requirement for a data scientist. What do you need to know? So for building up your resume, in your resume, what all will you put? The first thing will definitely be your education. So you can either usually computer science engineers are hired, or people from a mathematics background, people who are having PhDs, or your math, who have done their math honors, bachelor's in math or masters in math, or masters in data analytics, masters in data science. So these kind of roles, or these kind of educational backgrounds, people from these kind of educational backgrounds are hired generally as data scientists. Okay, so that is one thing, your education. Then following your education will come your work experience. So most of you will be freshers or fresh out of college. So you can give in your internship background, or what all internships you have done. So you can take up internships at small startups, or you have data science internships that are listed on Internshala from different startups and different companies. So you can apply there, and you can get into small startup. Start with small projects, and you can uh, scale up eventually. So that is important. So you can do a couple of internships um in companies and get an experience of how data science works in the industry. And then very important thing is you have your projects. So you need to have at least 2 to 3 very good projects in data science. So how do you start learning? How do you start the projects, right? So how do you know which is a big project, which is a small project? So what usually happens is uh, you have your small projects, like which start with uh, everybody in the field of data science starts with projects like wine prediction, and you have your uh, yeah, so you have a wine prediction, you have your uh, basically your wine quality prediction. You have iris flower subspecies prediction. So these kind of projects are the very basic projects that you start with while learning. So once you are done with these, when you're a complete fresher and you've never touched data science, that's when you can take up these small projects, and you uh, uh, learn through these projects. Once these are done, you can move on to little bigger projects, and projects where you actually need to apply, so do some analysis on the data set. Then you need to first you have to look for the data set, do some research on the data set. Then you have to do your data cleaning, um, data preparation, and all these steps. And once that is done, you then move on to what algorithm you're going to use, and decide upon that. And then you train your model, test your model. So all projects where you require to do all these things would be considered as a little bigger projects. So you have projects like sentiment analysis, you can go into disease prediction, tumors prediction, lung cancer prediction. All these things are breast cancer prediction. So these projects are a little on the higher side. So based on this, you need to do some good projects, and you can put your uh, best projects on your resume. So 2 to 3 projects should be good on your resume. And definitely the interviewers will be going deep into these projects, because they want to understand what you have actually done and how you have done it. So that is very important. And apart from your projects, what has always given advantage for me, or what I have always done, is I've actively done research. So I have a good number of 5 or 6 research papers published in good conferences and journals. So what this does is, when you try to convert one of your unique projects into a research paper, you do a lot of research about your own project. Like, is there any other project which is doing the same thing? Have they used the similar kind of algorithms, or have they used something else? Can we make an update, or can we push our algorithm to the next level? Is our accuracies and our scores better than the ones that are already there? So you do a lot of research on the existing works, so that will definitely help you learn a lot and also get updated. So that is one important thing that I have done and have found advantageous. So research is very important, and I've always taken part in hackathons. If you're especially in college, that is actually, in fact, how I also got my placement at Optum. So that is another important thing that you can uh, do. Then you have, apart from this, you also have your basic skill learning. Like you have to understand how the different algorithms are working, and what are the statistics that are, you don't need to go in deep into the calculus or the statistics that are happening there, but at least a basic understanding is required. So that is for that you can do different courses which you can also list on your resume. So you have courses like from websites or from institutes like Coding Ninjas, where you get certified in data science, or you have your Coursera where you can get more onto the application side. So all these things are very important and crucial for your resume for you to become a data scientist. So that's all I had for this video. I'm sorry for the disturbance that happened in between. Somehow there was some issue. So I'm sorry about that. And I hope you had a great time and you got to learn a lot. And I would also like to say that Coding Ninjas has this new series on data science on YouTube. The link to that is given in the description below. And the course that it has on that Coding Ninjas has it's on their website is also very good. That also comes with 12 projects. So those projects will definitely help you boost your resume as well. And apart from that, the link to that is also given in the description below. You can also get a scholarship on that by giving a scholarship test, which happens weekly. The link to that is also given in the description below. So I hope you had a great time watching or going through this session. And if you did, like this video or like this session, and thank you for watching. I hope you have a great learning experience ahead.